Hey guys, today we are going to be doing what would basically be very similar to a lab that we have done in class. We have been taking a look at density these last few days. We saw some examples the other day, and so we've looked at the equations on how to solve for it, things of that type of thing. And so we want to actually apply some of this in lab and understand how we would find density of some different objects. So I'm kind of shortening it compared to what we would have done in class, and you're basically going to need a piece of paper. You're going to take some notes and you're going to solve and try and figure out the density of 3 different items. So one of the things that we're going to find the density of is a rubber stopper. The next, we're going to try and find the density of an aluminum cube. And then finally, we are going to find the density of water. All right. So we know that when we're working with density, we have an equation that we're using. We know that density is equal to mass over volume, so we want to try and be applying that when we're working. So let's go ahead and take a look at what kind of measurements we're going to be taking. All right, so for the first one here, sorry that's shaking. For the first one, we have our aluminum cube, and we know that we are trying to find the mass and the volume. So for the cube, because we have length, width, and height, we could go ahead and take this measure ourselves. So why don't you guys go ahead and take a look at what we have on this ruler. Remember that when we take our measurements, we measure to the fullest extent of the measurement. When we're doing our density calculations, we should be using significant figures in everything we do. So let's make sure that we're reading this as accurately and precisely as possible. So what would you record for this? Let's put that down on a piece of paper. So we're measuring in centimeters for this. I know that it says millimeters here, but that indicating that the smallest units are millimeters, so we're counting by centimeters on that scale. So that was our centimeters. Let's go ahead and take a look at what our mass would be. So we're going to go ahead and get a digital scale out here. Let's go ahead and zoom back out again. And so for the digital scale, we're going to go ahead and come over. We're going to take our aluminum cube and place it on the digital scale. So we've got 5.78. All right, 5.78. And that's going to take care of our first piece. The next thing that we're going to be taking a look at is our rubber stopper. Now, in order to find the volume for the rubber stopper, things are a little bit more difficult for us. It's not something that I'm going to easily be able to measure and use a formula for with my ruler. It's a little bit, it's got a little bit of an irregular shape. We see that the bottom is a different width than the top, the length isn't right, so we can't just use the volume of a cylinder. And in addition to that, we have a hole that goes all the way through it. Okay, so if we're looking at this hole, that's going to throw off any of our volume calculations. So what we want to do for something like this is determine our volume by displacement. So in this example, we're going to find the volume, but first, since we're standing right here by our digital scale, let's go ahead and find the mass. So we'll come over here, we're going to put our rubber stopper on there. Okay, so we'll record that value. And now let's go ahead and take a look at how we're going to find our volume. So we're looking at the graduated cylinder here. We're going to be using this graduated cylinder to find the volume of our rubber stopper now that we have the mass. So you'll notice that there's some liquid in the volume in the graduated cylinder already. The liquid, when you first glance, is a little bit hard to see, but the level is sitting right here. I'm going to put a piece of paper behind it a little bit. Sometimes that helps us just grab it with the eye. You can kind of see where it's at. And so let's go ahead and make our best estimate as to what the volume is right now. What would that volume be? So we can see there's a number 20 right here, there's a number 30 up here. and we've got all of those lines that are kind of popping with the light a little bit, and we can see where that level is. It's right about there. So record the volume of what's in our graduated cylinder. This is what we call the initial volume in the graduated cylinder. And now what we want to do is take that irregular object, so we've got that rubber stopper, and we're going to go ahead and drop it into the graduated cylinder, and we're going to see how the volume changes. So we're going to gently drop it in. I don't want it to go too fast so that it splashes everywhere. But now we can see that the volume has changed pretty significantly. So you need to record the new volume. Okay, so what would you put this volume at? Okay. So we should have all of the information that we need right now for our rubber stopper. The last thing that we're going to be finding the density for is water itself. So if we're trying to find the density of the water, we're going to need to get a mass and a volume. So the first thing that I'm going to get is the mass. Now, the deal is, I don't want to just go ahead and weigh the entire bottle. So I'm going to be pouring some of that water into a graduated cylinder. So if I pour the water into the graduated cylinder right now and fill it up, I'm going to have the mass of the glass included, and I don't want that. So remember, we have a couple of different ways that we can find that. We can either take the initial value of our graduated cylinder. So if I put this on the graduated cylinder, we see our initial value here. Or I can tare it. So right now we're reading 34.21, which is the mass of our cylinder. I'm going to clear that. So now it's reading 0, and I'm going to go ahead and put some liquid, some of the water, into this graduated cylinder. So I'm going to squirt it and fill it up. So let's go ahead. That amount weighs 6.0. All right, so we've got our mass. Now let's go ahead and read the graduated cylinder. So we're going to go ahead and take a look at the graduated cylinder here. See if I can get it to focus. Might be too busy in the background there. Let me see if this helps. That helps a bit. See if I can get to focus. There we go. Let's go ahead and read that close. All right. So we should be recording that the best we can. Now we have all of our data. All right, so now we've got all of our data. We've got our data for our water, we have our data for our rubber, and we have our data for the aluminum. And so using that data, we're gonna make sure that we organize everything neatly, and we're gonna clearly calculate and define what the density for each one of those things are. Now, when we're talking about these things, the densities for these values are what we say are experimental values. They're what we actually got in the lab. I would like you guys to go one step further and find how close were we. Now, I'm not going to make you do this for all of them. I just want you guys to do this for one item. I want you to find the percent error for our water. Water is published all over the internet in terms of what the density for water is supposed to be. It varies a little bit from one temperature to another, but the theoretical density of water is 1.000. So if you look back in some of our earlier notes when we talked about accuracy and precision, I told you guys how to calculate percent error. How do we see how close we got to the true value? So I want you to take your experimental density of water and compare it to the theoretical density of water, which is 1.000. and see what our percent error was. So I'll be looking for several things when you guys turn this activity in. I'm going to be looking for neatly labeled and identified measurements. If we took the measurement, it should be on there. I should see density calculations and our final densities in significant figures, making sure that we're using our sig figs. And finally, I should see a percent error calculation for water. Let me know if you guys have any questions, and I'll help you out the best I can.